Have you ever wondered why it is harder to open a bottle cap when you press on the opener close to the cap and easier when you press on the opposite side? Let's prove the same experimentally. When the opener was pressed close to the bottle cap, it required 5.8 kg of force to open it. On the other hand, when the opener was pressed away from the bottle cap, it required just 1.7 kg of force to open it. But why does the required force changes with the position of the effort? To answer this, we first need to imagine a rod floating in deep outer space and think of the path it will follow when hit the different positions, the center versus the extreme end. I have used an air levitated football and connected 5 such toys side by side to mimic a rod floating in deep outer space. Now let's see what's happened when I hit the setup at different positions. When hit at the center, the setup moved 175 cm along straight line and did not rotate at all. When hit at an off center, the setup moved 160 cm linearly and also rotated by 225 degrees. When hit at the extreme end, the setup moved 140 cm linearly and also rotated by 480 degrees. From these observations, we can conclude that the force applied by us gets divided into two parts. One produces linear motion while other produces rotational motion. A force applied at the center produces pure linear motion. But as we move away from the center, the linear motion decreases while the rotational motion increases. Now let's apply these conclusions to the cap opener problem. When we press close to the cap, that is new center of the system, the linear motion dominates, which tends to push the bottle and the cap downwards. But when we press away from the cap, the rotational motion dominates, which tends to lift the cap from one side. But wait, these were just observations. We haven't yet explored the science behind them. For that, let's study the various forces involved when this setup is hit at different positions, that is the center, the off center and the extreme end. Now by simulating these forces in Scratch software, we can clearly see that the rotational motion increases as the impact point moves away from the center.